My name is Mrigank Aditya, and this is my partner Aditya, and together we made the long one. The challenge was to create a robot that could navigate through a maze, which was a white tape, and sense a wall using an ultrasonic sensor and catapult pennies into a tray. This is what the maze looked like over here. And this is the wall and the tray, which can't be seen, but is right behind the wall. The constraints were we were only allowed to use 3 motors, an NXT, an ultrasonic sensor, a light sensor, and only use Mindstorm Lego pieces. These are the Mindstorm Lego pieces. These are the motors. This is an NXT, that's an ultrasonic sensor, and that's a light sensor. Features and benefits. We had a catapult with a long arm because with a longer arm, the power is increased of the throw. You can think of it as a baseball throw. If you throw the ball like that, the ball's not going to go anywhere. But if you throw it like that, the ball's going to get more distance. But if you throw it with your full arm, the ball's going to get the maximum distance. We also had the NXT placed in the center so that the robot would be symmetrical and it wouldn't veer off into other directions. Our light sensor is facing down, which is shown here, so that it could sense the color of the tape because the tape was on the ground. And our ultrasonic sensor was low because, as you can see, our robot was pretty high. And if you put the ultrasonic sensor on top, the ultrasonic sensor wouldn't be able to sense the wall. You can see here a catapult with the arm being that gray rod, and our NXT placed in the center of our robot. And we also included a chassis, which is this. The chassis is the framework of the NXT to hold it in place. And without a chassis, it's very difficult to make a robot. Then we also included 2 motors for the treads so that the power would be increased for the treads and it would be able to go faster.
The cons are that there's not enough catapult power here, and it's a very unstable chassis, and there's very slow turning. It can't turn very well because it's going a bit fast, and it's very heavy, as you can see. The chassis, as you can see, is made of rods and these bricks, and it was made with rods and bars, but we decided that it wasn't stable enough, so we switched them to rods and bricks. Catapult was weak, so we changed the arm length by adding extra bars and added these, and we took off a lot of unnecessary decorations, so it's all functional. So what happens is it moves when there's nothing in front of it, and so it goes over here, and over here at the top it says it moves to the right when it sees the black, and moves to the left when it sees the white to follow the white line. And over here, if it does sense the wall at 6 inches, it stops the treads, and it shoots the catapults over here, and it shuts down the program. If we could do this again, we would first use wheels, or maybe have more power, more treads on the robot. Definitely more motors so we could increase the power. We would want to get the catapult off the table and have it stabilized so we could just shoot like this instead of having to go all over. And we definitely have a more stable chassis than just these two, this small framework. And definitely more weight so that we could have a better turning. Reflections, our project progressed relatively slowly than other projects. We didn't really communicate well due to the fact that I wasn't here for half the time, and while decisions weren't discussed in detail because we were doing separate things to get our project finished faster, and we could have communicated better to work on the same thing at the same time so that we would finish more faster on what we wanted to finish. And we learned that the chassis was definitely necessary so that this wouldn't keep wobbling around and that we would have a better catapult and everything. And we also learned how to program light sensors to do more than just sense different lights. We actually used the light sensor to control the robot. And this project was quite challenging and frustrating in trying to fine-tune every single little problem. We went with mostly our own ideas instead of following what other teams did because we wanted to get better in doing different things, and we combined lots of ideas. And we didn't have much time because we goofed off a lot. And we learned that a blueprint is necessary and cables can't block sensors or else they'll give misinformation.
And also, with doing our own ideas, we didn't just not use the other people's, our colleagues' design, but we also had disagreements in our group itself for the design.
Any questions?